Okay, so you have previously learned how to calculate the z-score and what the z-score means and all that. And in this video, we're going to learn how to take the z-score and apply it to the unit normal table, or the z-table. So as a refresher, to calculate the z-score, it is equal to x minus mu over sigma, where x is your score of interest, mu is the population mean, and sigma is the population standard deviation. So since the numerator of this ratio is not the absolute value, that means the z-score can be positive or negative, and the z-score lets you know how many standard deviations your x-score is either above or below the mean. So let's say, for example, our z that we calculate is 0.60, and now we want to use this unit table to figure out what this 0.6 actually means. So as you can see, you have z values in one column, proportion in body in one column, and proportion in tail in its second column. So the first thing you should always do to keep track of everything and makes things easier when you come to the unit table is to plot your normal curve, your 0 standard deviations right there down the middle, and then you should plot your new z-score that you calculated. So we have 0.60, and now the z-table looks, these numbers, the proportion in body and proportion in tail, these represent probabilities, and the way you read this is you'll be asked questions. It'll be sort of, so you have your z-score 0.6, so a question could be like, what probability of scores are above a z-score of 0.60? So since it asks above 0.60, you take your normal curve and you shade to the right of 0.6, because those are all the scores that are above that z-score. So now when you come to the z-table, first you want to go down your z column. In this case, our z is 0.6. Now you might be wondering whether we'll be using the proportion in body column or the proportion in tail column. So if you look back at our normal curve over here, the way you decide which column you use is based on whether the shaded area of your graph is more or less than 50% of the total graph. Now 50% is at this 0 standard deviation mark. So since our z-score of 0.6 and it's shaded to the right, that is less than 50%. So we're going to use the proportion in tail column. So we go down to 0.6 for our z-score, and since it's less than 50%, we use the 0.2743. So that means the probability of having a score above a z-score of 0.6 is 0.2743, or 27.43%. So say the question instead asked what would be the probability of getting a score that is below a z-score of 0.6. Then we would shade to the left of the graph of the 0.6 mark, and that would be more than 50% of the graph would be shaded. So we would use the proportion in body column instead, and we'd see that the probability then is 0.7257 instead of 0.2743. And that is how you use the z-table with the z-score that you have calculated.